Good morning, ladies and gentlemen. Today, you guys are going to be locating the images formed by mirrors using a ray model diagram.
Yep, we need to know where those images are, we need to describe them, and we're going to use ray model diagrams at dope.
I remember these so fondly from college. Okay, so the image produced by a mirror can be located by making a ray model diagram.
So boys and girls, you're going to need a pencil and a ruler
Of some sort. Okay. All right, so it says draw an arrow, height 2
Well, first of all,
centimeters.
let's set it up.
Yeah. Where's my stuff? Okay, so we're gonna go ahead and start by drawing our principal axis.
So draw a straight line, make it at least 16 millimeters long. I beg your pardon, centimeters.
Okay. Well, that is harder to draw than I thought. Okay.
Okay, now did you go all the way to the end of your?
Oh no, I didn't. I went to 80. Let me go back.
Well,
I'm gonna redo it. I didn't like that line anyways. Okay, so here we go. Wow, it's hard to hold it up there straight, huh?
yep.
Okay, plus this marker is dying. I'm gonna get that other black one. Okay. Okay. All right, and then I'm gonna go ahead and just draw.
Okay, you cannot freehand it. You have to use the protractor.
Yeah. Oh, I can use this guy right here. Okay, I'm gonna draw this guy right here.
It has to be perpendicular. We can't draw the mirror accurately, but we can get good results if we just use a protractor to do a perpendicular at the
And
end.
so how do I know if it's perpendicular? It's lined up with the 90 right here. I've got my axis over there. Miss Moore has to push it down hard, and she draws it. Wow, what is? Maybe it's just because I'm using it on this thing, huh?
Yeah.
Okay. All right. So draw an arrow, height 2 centimeters.
Oh, well,
as the
first of all,
object.
the center of curvature for this mirror is 12. It's the same one we were talking about
Oh
yesterday.
yeah. Okay.
So we need to measure the center of curvature.
So 12 times 5. That's 60, right, Boykin?
Yes, ma'am.
Okay. Okay. So you're gonna draw yours.
So measure 12 centimeters from the mirror, and that vertical line is the mirror.
Okay. And so mine is gonna be.
Make a
right
mark
there.
and mark it with the letter C.
Okay. So this is my curvature.
Now,
I'm sorry, my
if
center.
the center of curvature is 12 centimeters, where would the focal point be?
6.
Half of that.
Right. Okay. So I'll go ahead and line
So
this up
draw,
on
measure, and locate, and draw a dot, and label it F for the focal point.
Okay. So I'm gonna go ahead and say my focal point is what did we say? 6 centimeters.
6 centimeters.
Okay, and I'm just gonna go ahead and label this as well. You know what? I'm gonna put it up here.
And the height of the object is going to be 2 centimeters, and the distance of the object is 14 centimeters. So you need to measure 14 centimeters from the mirror and make a mark.
Okay, so 14 centimeters. So 14.
We have to do a calculation because that's a meter long.
Okay, so ours is gonna be our arrow. Our object is gonna be right over here.
So boys and girls, you're doing the same thing we are at the same time. Don't just sit here and attempt to be entertained.
Yeah, I am entertaining, but okay. So our distance of the object is that, and then we said it's 2 centimeters tall.
Yeah, so we want to, and you want to have the, arrow represent your object. You want to draw the tail of the arrow on the principal axis, and you want the, you need a ruler?
No, this one's, that was in millimeters. I'm just gonna go with this one. But like, and we said 10 was from the middle.
Yeah, so go ahead and put it on the, and measure 2 centimeters on your protractor.
Yeah. Okay, so right. Okay.
Draw an arrowhead on both sides. Yeah. Okay, so now you put the H sub O, height of the object, is 2 centimeters. So now,
Boom. Now we're
got-
done.
we've got the object on the principal axis represented by an arrow. The tail is on the principal axis, and the head is represented by the arrowhead.
Okay, we good? You guys good with this?
So we got something that looks like this.
Sweet. Okay, now it says draw a ray from the point of the arrow to the mirror parallel to the principal axis.
How can you make it parallel?
Okay.
What can we do to make it parallel? Because ray model diagrams obey the law of GIGO.
Yeah.
Garbage in, garbage out.
So I think if I measured this, if this was 2 centimeters, I can measure 2 centimeters over here,
That
right?
would make it parallel.
Okay.
So measure on your principal axis, boys and girls, 2 centimeters, I beg your pardon, on your mirror, 2 centimeters above the principal axis, make a mark.
2 centimeters. Okay, it's gonna be right there. Bada boom. Okay.
And
so
then
there.
connect the tip of the arrowhead to that.
Connect the dots here. No. Make sure I can hold it in there. Okay.
Draw an arrowhead on it. There you go.
Voila!
All right.
Look at that line. That's a good looking
It
line.
sure looks parallel to me.
Yeah. That looks like it might be
All right.
down
So
on my
if
head.
if you haven't finished this, stop until you do.
Okay. Reflect that ray from the mirror through the focal point.
So it comes in parallel, and then it has to go through the focal point.
Huh, just like that thing we did, that handout, right?
Yeah.
Just like the sun does, okay? So we'll go right here, right there. It's really hard with this marker. Okay.
And draw it as far as you can. There you go. And then put an arrow on it.
Okay, so there we go. All right, what's next? Oh, and if you haven't done this, pause it and do it.
Yep.
Okay.
So in parallel, out through the focal point.
All right, now draw another ray from the point of the arrow through the focal point of the mirror.
To the mirror.
Oh, to the mirror, sorry. Okay. So that means I'm going from here through here to the mirror, right?
Yes, ma'am.
Okay, so here we go, from here to here. Oh, and you can see I missed the focal point a little bit right there.
Yep. So that will affect your results.
Yeah. Okay, let's see if I can get this. Okay, so focal
I always use a pencil when I do these because I make mistakes.
What?
Put an arrowhead on that.
Okay, yeah.
It's not a ray if it doesn't have an arrowhead on it.
Yep.
Okay,
Just a line then.
So we've got one from the tip of our object through the focal point to the mirror.
Okay, and then draw another ray from the point of the arrow. I just did this one. Okay, reflect this ray out parallel to the principal axis.
How can we make it parallel?
Gotta measure again. Okay, so I'm gonna go ahead and just say.
Well, put it there.
So we're gonna go from from that mark to the 10. Okay, so from that mark, okay, to the 10, so right there is what I'm going for.
So this is what we're doing is our first ray came in parallel, reflected through the focal point. The second ray goes through the focal point and reflects out parallel. Is that parallel?
It's as parallel as we're gonna get.
I think so.
So I measured here and I measured there. Okay.
What's next?
All right, next slide. Okay. Ooh. Okay, the image is located where the two reflected rays intersect. Okay, so right here. Draw an arrow with the base on the principal axis and the point at the intersection.
Okay, now you're going to use your protractor. Do
Yeah.
not freehand this.
Don't freehand. So right here is where they cross at.
Yeah.
Okay, so
You want that. You want the arrow to be perpendicular to your principal axis. Put an arrowhead on it.
okay. Alright. So what's next? Alright, so measure the height of the image in the distance from the mirror to the image. Okay, so okay, so the height of the image here, let's see. Okay, we're gonna say
Now for yours, you measure the height while we do that. You're going to have to divide by 5.
Boykin, do you measure from the very bottom of the ruler here or for the first tick starts here?
Well, you can whatever you want. You
Yeah.
can't really tell. For
I know,
This.
I just realized. Okay, we'll call it 8.5, I guess.
Okay, now you have to divide that by 5. That's not the actual.
Yeah, so that's not for you guys. 8.5 divided by 5. Okay, so 1.7.
So that's the 8 sub I.
Oh, sorry, yeah. The height of the image. Excuse me.
is 1.7. Now
Okay.
this is 2, that's
1.7?
1.7. That doesn't look right to me. Grab another ruler here.
Yeah.
That's 7 centimeters. What'd you say it was?
I said a what? I said 8.5. Ah, let's call it 8.
No, let's call it 7.5.
7.5. Okay, so 7.5. You know what I'm finding is it's hard to. We'll call it 1.5 then.
So 1.5, that makes a difference.
Yeah.
So this is 2, this is 1.5.
1.5.
Now the distance from the mirror to where the intersection is.
Okay, so here's our intersection.
So you boys and girls measure yours. We're measuring ours. And that'll be the distance to the image.
And I get 11.1. You know, let me go like this. Like that. Boom. Okay.
11.1, and that's reasonable since this is 12. That's about 11, and yeah.
It makes sense right there.
Okay, now let me point out something that's very important. What determines the height of our arrow? It's where this ray came through and struck the mirror. So you'll notice that whatever you measure for this right here is going to be the height of the image.
Oh. Okay, wait, say that one more time, Boykin. Whatever I measure for this right here?
Well, because this line is parallel to the principal axis,
Uh-huh.
wherever this strikes on the mirror, that's going to be the height of the image.
Okay, I like that. Okay. So we have a few other ones.
Well, what's next?
It's this one right here.
Okay.
Okay, so should I maybe lift this up here and do it underneath, or should I just erase this guy? They've got it written down.
Yeah. It's up to you.
All right, we'll just erase.
So we're going to do a total of 4 of these, boys and girls.
I know,
We've got
I know.
1.
Okay, so I'm just gonna erase all my beautiful work. Okay.
So now do the same thing. Draw your principal axis. Draw a mirror perpendicular at one end.
Okay. And is my focal point and my axis still the same here?
Yeah, it's still
6 centimeters and 12 centimeters.
yep.
Okay, but now my distance of the object is 16.
So we're going to move the object out. Based on what we've seen before,
Yeah.
where should the image be compared to what we did a minute ago?
Okay, if we're moving it out, what's gonna happen to it? Okay. Dang it. It's so hard to draw this first line.
Well, the trick is, how do you hold the ruler steady
Yeah.
against the board?
There we go. I almost got it that time. Okay. Here we go.
Also, these rulers are seldom straight. And what I'll do is I'll do like this, and one side is more stable than the other.
Okay, and then you know what? I probably should have left my my focal point and everything up there. So 12 times 5, that's 60, right? Okay.
So the center curvature is at 12 centimeters, and the focal point is at 6. So draw your focal point, draw your center of curvature, and label them.
Right there. Yeah. Okay. So boom, boom. Oh, that doesn't look like it's in the middle, does it?
Yeah,
You good?
yeah, it's just your line is gets wider and smaller.
Yeah. Okay, so what next? We got to draw our
So now we need
object,
to
right?
locate the object, which is going to be an arrow, and we want to measure 16 centimeters from the, which is going to be 80 for us. So measure 16 centimeters from the mirror, and that's where you're going to put
16 times
the object.
5 is 80, you said, Boykin?
Yeah.
Okay. Human.
What the heck is going on outside?
I don't know. What is it?
I don't know.
Just hanging out? Okay, so
Sounds
the
like a
distance
skateboard.
of the image is 16 centimeters. So I'm gonna put my arrow right here.
And we're going to use the same height, 2 centimeters. So you
Yeah.
need to use your protractor.
So that's gonna be 10. Okay, so here we go. From here to here.
And you want that object to be perpendicular. If it's not, it'll affect the outcome.
Okay.
So there's our object. There's our height. So what's the first line we draw?
The first line, well, the first thing we need to do is figure out, I'm actually going to measure with this time, just so I can get right on the money here. So 4. We first need to draw our parallel ray coming in. Okay, which means we have to figure out, we have to make sure we have the height
So
here,
boys and
so
girls,
it's
you
parallel.
go ahead. Let's see if you can do this faster
Yeah.
than Ms. Moore.
Do it,
Ms.
do
Moore
it.
is not going to try to go fast. You're going to try to be accurate.
Yeah.
Keisha Hildreth, please report to the
I
SVO.
know her. Okay. Oh, mother pepper. Okay. Ow. Ah. Okay, I gotta redraw that one. Wait, can you make it look so easy?
Well, you know, after doing it for 20 some odd years.
Okay. Push down, go fast. That's what I'm telling myself. Okay. All right, so there's my thing, and then we gotta draw it through the focal point.
And you need to put an arrowhead on every ray that you
Oh.
draw. Otherwise, it's not a ray, it's a line. So now reflect that through the focal point and as far as you can.
And you notice I got a little wobbly there, so that's gonna affect it. Okay, so then from here,
Now the next ray comes in through the focal point and goes out parallel.
those are the rules.
And basically what we're doing, we're following the same thing we did with this. All right, now, and then that has to go out parallel. How can we make it parallel? And also remember, this is going to be our height of our object. Is determined on where it strikes.
Gosh, numbers. I gotta double check that. So we said over here, this is we'll call 2.6. So 2.6.
And now remember, we're doing this big on the board. You're doing it actual size on your paper. So what we have to do is we have to use a scale.
Yeah.
That scale is over here for those of you who care. No, that's nobody. Okay, nobody cares.
Okay.
Now draw your line out parallel. Comes in through the focal point and out parallel.
Where'd it go? Right there. All right. Okay.
And the image is located where they cross.
So it's
So you use your protractor.
there. There it is.
All right.
Okay. And I said the height of my object, I measured it just now, and I got 0.52 centimeters.
So the height of the image is 0.52 centimeters.
And then the distance to the image. Measure.
So you have to, and see what she's doing. She's labeling everything. She's got the center curvature, she's got the focal length, she's got the distance of the image, the height of the, I beg your pardon, the distance of the object, the height of the object. And then you measure the height of the image and the distance to the image.
All right, I got around 9.7.
And that should be, that's about good because F is 6 centimeters and C is 12.
Okay. Sweet. Okay, so, and you guys can see the relationship as we get further out and how that was compared to the last one.
So you're going to have to show us, you can draw a ray model diagram, and here's a complete ray model diagram. Now, understand there's some uncertainty about these results because, did that hit right exactly on the focal point? Is that right exactly? You know, there at every, where does error occur?
Yeah.
It occurs every time you do something.
Yeah, especially Miss Moore right now.
Well, no, it's appropriate.
Okay, oh, notice the subtle difference. What do we have here? It was 16, now we're going to 12.
So, boys and girls, you do this one on your own.
And then there's one more after this, which is 10.
So,
So they'll do both of those.
the height of the object is going to be the same each time. Let's do 2 more free body diagrams. The next one will be 12 centimeters, and then the last one will be 10 centimeters. And we'll talk to you about this tomorrow.
Okay. Is
Okay.
that my... oh, we do have one more slide. It's
Oh,
this one right here.
no. Oh, we want this. Go to the next one. Okay.
Oh, that's what I
You
want.
can
Sorry.
check the
This thing is
accuracy
glitching. Okay. So you
of
can
your
check
diagram by making a third ray.
from the tip of the arrow to the center point. Okay, so let's see how we did here. Okay. So here's the tip of the arrow. There's the center point right there.
You use the meter stick.
Oh yeah, okay.
Good morning, Golden Valley. This is Principal Swartwood. Congratulations to our boys and girls track teams. Both of these groups competed against all the other teams in our league yesterday.
Not bad.
Golden Valley's Veterans Stadium.
So what does that mean? It means it should be right there.
Yeah, so that's a way to check the accuracy of your drawing. You get the one that comes in parallel out to the focal point, comes through the focal point and out parallel. And if you draw it through the center of curvature, through the image, all three. And now why is that true? Because if it goes through the center of curvature, that's a radius. It'll come back on the same line because that's normal to the tangent.
All right, and that's it. So do those 2 other ones.